This is a lab for bar magnets by Caitlin Schmidt. So the purpose of this lab is to observe and measure how the magnetic field of a small bar magnet changes with distance, compare the measured distance dependence to the predicted distance for an on-axis and off-axis magnetic fields, and the predictions are derived from the Biot-Savart law. These are the Q findings, which is both N and mu. Here are the key principles, which are both the Biot-Savart law, the B field of a dipole, and the power law, and I included the description and the equations for both. So for the observed model or the experimental model, these are some diagrams that show you what it looked like, and the initial conditions were the bar magnet and the magnetometer app on the iPhone, and the systems of bar magnet and surroundings are everything else. Here are the calculations and data for the observed model, and all of these were just plugged into the given Excel sheet from the app. My calculations for mu, k, and n using the linearized formula. And then here are the data for the off-axis part. And this was also done using the Excel spreadsheet. The observations for that is that there seems to be a direct relationship between distance and magnetic field strength, and when the magnetometer is far from the magnet, it registers an X component of the magnetic field that is close to 0. As the magnetometer is brought closer to the magnet, the measured X component increases in magnitude, and so it's observed that the magnetic field strength is inversely related to distance. Using this finding and using the starter code, here is the computational model, and these are the initial conditions that were calculated. So it includes the mu and the B field of a point charge, basically, and that is the equation that was in the key principles. Here is the next part of the model, which is basically just calculating how the arrows are going to show up and the observation locations. It's about the same here, and this is just showing the end of the code. Results for the computational model, and this is what the magnetic field looks like, and also the calculations are shown on the left. Model discrepancies are that the observed model off-axis field was 6.38 times 10 to the negative fifth power, and the computation model off-axis field was 1.76 times 10 to the negative fifth power. And the potential errors are that the electronic devices in the surroundings could have altered the readings, and human error using the app. And assumptions are that the bar magnet acts as a magnetic dipole, so we can apply the Biot-Savart law, and external forces are negligible. For the discussion and the first what if question, so my response is that the results would be inaccurate because the magnetometer measures the net magnetic field, and since it is a constant and non-zero, it would offset all of our readings, and the data would be too skewed to accurately present it. And then for the second what if question, the magnets would act as a single magnet with an approximately doubled magnetic field, and most importantly, the field strength would be approximately twice what it was for a single magnet. However, the fundamental way a magnet decays with distance would not change because the system is still a magnetic dipole, and therefore the direction would stay the same. Thank you for listening.